I'm Miranda Smith. Currently, I'm getting my bachelor's at OSU. My field is in education, specifically primary education and visual impairment education. So I will graduate with my teaching license for elementary, as well as my intervention specialist license for K through 12 for visual impairments.
I'm Brianna Watts. I'm going through the exact same program as Miranda. So I am going for my bachelor's at OSU right now. On track to get my primary education license, PK through 5, and my visual impairment license K through 12.
And I'm Kenjiro Nakayama, a PhD student at the University of Tsukuba and majoring in psychogeriatrics in medical science. Thank you.
Yeah, sorry for the noise. I'm also the same program as Luis, Nicholas. Nice to be here with all of you. Thank you so much.
So before we start going into our identified problem and our proposed products, we wanted to give a little background about what orientation and mobility is, as well as assistive technology. So orientation and mobility is essentially the act of helping people with visual impairments learn how to navigate independently. So orientation, knowing where you are and relative to other locations and landmarks, as well as mobility, being able to travel independently. This primarily began in the post-World War I era because of newly blinded war veterans. They especially used guide dogs during this era to help them navigate around, but the term orientation and mobility was not used recently until the 1950s, which means that it's still a recent thing that we are working our way towards and still developing in. Even still, like as you can see, the first college program for O&M did not start until the 1960s. So this is still a very new topic that we're developing through, especially because people with visual impairments have been a part of our population for as long as we can remember. So the fact that now we are making gains towards helping them become independent is really important. Certified Orientation and Mobility Specialists, also known as COMS. These are the people, the professionals that work with people with visual impairments through all ages, from infant to elderly, learn how to navigate independently on their own. You can go to the next slide. So overall, the goals of O&M is to empower the individuals that are visually impaired, to empower them towards independence, which is one of the ultimate goals of any professional that works in the field with people with visual impairments, because it can be very difficult for them to gain independence, as well as avocation. It's really important that people who have these exceptionalities are able to advocate for themselves, for their own needs, and for ultimately can what can provide them the support to get independence. You can go to the next slide. Sorry, we also wanted to give a little background about Braille and embossing because these are two very big parts of assistive technology as well. Braille is the tactile writing system for people with visual impairments. It is 6 raised dots, two columns, or yeah, two columns, 3 rows, and based on which dot is raised is corresponding to either a letter or a phrase. It can ultimately go farther than that. Like a lot, there's single cells, single like raised dots that represent words. And it was created by a young man named Louis Blind. And he was the one who developed the system Braille. And embossing is one of the ways that people are able to read Braille tactily, using embossing machines and other Braille creating devices like Braille writers and slate and styluses. They're able to transcribe a lot of different languages into Braille. But because of the amount of space that Braille can take up, it there's a lot of hard work that goes into transcribing. So using tools like online digital tools like PerkyDuck and Duxbury can be really important because it limits the amount of time that a person has to spend on transcribing a piece of writing or literature into Braille. You can go to the next slide.
All right, assistive technology. Um, the first thing we wanted to talk about with this is what it is. Assistive technologies are used by people with disabilities to better access things that would be difficult without the use of them. There are two categories. There can be electronic and non-electronic assistive technology. These support people with exceptionalities in many different ways and in many different domains. This is important because it is required under the IDEA, the Individuals with Disabilities Education Act, as it falls under the FAPE, the Free and Appropriate Public Education. The access to these help people with all different abilities maintain or improve functioning, as well as accessing things like employment, education, and just their independence in general. Is obtained through the Assistive Technology Acts, where there is federal funding that is utilized to provide people with visual impairments of all ages with assistive technology. Not all of these will qualify for certain grants, making some of these assistive technologies very difficult to obtain, as well as some of these assistive technologies being extremely expensive, making it a little bit more difficult to access if it cannot be covered by a federal grant. Go to the next slide, please. According to the IDEA, if an assistive technology is identified as a part of a student's IEP, it must be provided by the school's district at no cost to the student or the student's family. And you can go to the next slide. An example of a mobility assistive technology classified as a physical aid. An example of this is a white cane or a wheelchair. These aids are used as a way to support people with visual impairments' ability to travel independently in areas that are well-known or maybe unknown. Over time, there are many techniques that utilize this cane or mobility aid that have become popularized and implemented in the field of O&M, orientation mobility. You can see here to the left, there is a folding cane. This one's a little bit more versatile for the students. They can put it in their book bags, or it's just a little bit easier to hold versus a rigid straight cane where you have to leave it unfolded the whole time. It's a little bit more bulky and hard to place certain ways. Go ahead and go to the next slide. Braille-related assistive technology. One example of this is the Braille writer. Students are able to write in Braille using this. There are 6 keys, each representing one of the 6 raised dots in the Braille cell. Using their knowledge of the keys, they are able to write Braille. This allows students and individuals in general to write for schoolwork, write lists that may be needed, like for groceries, and more. Creates more accessibility just to their environment in general. Another example of a Braille-related assistive technology is the Braille Note Touch. This allows for access to the internet. Individuals can read through websites, articles, books, and more. Anything that you can access as a sighted person, for example, you'd be able to access on the Braille Note, not including like images. You could get descriptions with that. Individuals are also able to write in Braille. They touch the screen, and it's kind of used very similarly to a Braille writer, each finger representing a dot or a Braille cell. As they write with the touch screen, they can read over what they write at this bottom little area, and then they can check for errors and go back and rewrite things. You can go to the next slide.
So I'm going to come back and talk about the implications of everything that we just discussed. So we talked a little bit about IDEA and how that applies to students in schools, but you don't only have a visual impairment while you're in school, it also expands into adulthood and even elderly. So we wanted to discuss early childhood, which it's really essential that these impairments are addressed early because it helps identify the students' needs and it helps expose them to assistive technology at a younger age so they're more used to it. During the childhood ages, like we mentioned before, an IEP is a really big part of a student's ability to learn in school. And an assistive technology, it's really important for any kind of technology that they think they might need at any point to be included in that IEP, just so they can have that resource. In adulthood, some students um, remain in school until they're 22. But after they turn 18, their IEP becomes something that they handle themselves. So it's really important that they are able to advocate for themselves in place of a parent or a guardian. And finally, adults. In adulthood, they have many opportunities, like opportunities for Ohioans with disabilities, is an example here in Ohio, that can help that can help them provide, or that, sorry, that helps provide them with job opportunities and funding for different universities and degrees, but it can be difficult for them to obtain assistive technology past adulthood because it is not covered by things like IEPs once they're in, like while they're still in school. So things like braille writers, they are around 800 a piece. They are very expensive and they can be really hard to obtain as an adult, especially if you want to use them as you become older. You can go to the next slide.
So first, I would like for you to imagine yourself in this situation as an adult right now. Like we know that the loss of vision is also a problem among the older populations. So imagine yourself facing this problem of if you wake up tomorrow having low vision or functional blindness, how would you what would you do about the situation? Or if you have a kid, for example, you have to provide your children with like assistive technology for it. And normally, I believe that most people's response to that will be trying to find some type of assistive technology that would support them. For example, the professors here would try to find some printer or something like that where they could read their research papers. Or you just could find some assistive technology that can take you from your home to your lab, for example. And for most people, I feel especially us in the engineering department, that would be the first instinct, right? Go after the technology that supports you. But the problem is, in the context of assistive technology, if you look at the user's average response to it, this is an example I got from a forum, the overall experience with assistive technology is not exactly good. So for example, I can mention this last one comment here. The overall idea, the overall perception from the users is that usually assistive technology is very expensive and it's just not there yet. This is directly from this last user here. That's essentially a consultant for this type of technology for low vision people. And usually the overall experience is just not great. So that was the case for more modern assistive technologies, more experimental things. But even for more consolidated markets, so for example, we have braille printers that have been around for quite a while. If you look at the price tags, I think it pretty much like you can see here, they usually go for around here on the person here. It goes from anything between $1,000, $1,500, all the way to $20,000 for a single braille printer for the ones with more function, right? So that's very inaccessible. And even if you take the cheapest one, the more affordable one in this case, it is still like $1,500, and that's just for the device. You also need to pay for the software separately. Just in context for something that's more closer to that we can understand and compare to, like a modern 3D printer, a high-end 3D printer for the user nowadays costs 3 times less than the cheapest braille embosser that we can find on the market. This is a very big difference. This is a high-end 3D printer versus the cheapest embosser you can find. And for the cheapest 3D printer you can find, the cheapest braille embosser is 10 times more expensive than that. This is usually something a user will be able to buy, but like a normal person probably would not be able to buy a very good braille printer for them, even if they wanted to. And this is also the case for other assistive technologies. So we were talking about embossers, but it's also the case for like vision. For example, smart glasses we have, they are very usually audio-based, which limits the functionality by a lot. They're very expensive. They're usually not very comfortable. They're very experimental. There is one example. It's also not very widely used. And we try to look for what are the main reasons for that, what are the cases for that, what are the causes for it. It's usually mostly due to the outdated technology and the lack of competition. So there's this perception that not a lot of people suffer from, like the market for this type of technology is not very big. So the companies, they pretty much have a monopoly in the market, and the same companies have been producing the same technology for things like decades right now. and they focus exclusively on business to business. So usually those braille printers I was mentioned is usually sold for businesses, for schools, for companies, and the users themselves usually don't have access to it. Our approach in this context is a little bit different. We are trying to address the most pressing needs of the users in a simple way. So there is through user collaboration, through talking with the users and understanding their concerns, we are trying to develop simple and low-cost affordable solutions using modern technologies. Our philosophy here would be foster independence and support the user autonomy. And we believe that technology should be accessible for everyone, and all the users should be able to feel complete ownership of their tools. That means no subscriptions, no fees, something that you can buy once and just change however you want to make it fit your needs. And with these ideas, we propose 2 initial products. So the first one we call the Spider Sense. It's basically a directional haptic navigation device. I have one very simple prototype here. I'll be showing to you later. And the second one is the tornasol printer. So this is basically trying to a modern approach to the classic braille printer that we already have, right? So let's start with the first product, the Spider Sense. Our idea here is usually, as it was mentioned before, the navigation devices usually have for low vision people, they are limited to the white canes and usually, for example, guide dogs, but they are also usually limited to the environment. So for example, for the canes, you need the pathways to be able to follow, or you need to be in an enclosed environment. They are not super convenient. And we are trying to develop something more in the sense of like closer to a smart glass, but simpler to the point that every single user can like cheaply buy one of those and use however they want. I have an example here for you to see. So this is the device. If you can see the zoom. This is the prototype we developed. It's a very simple prototype. It's just like a proof of concept to see if we could make something like that. And the idea is we have a sensor, this one, which behaves like pretty much like a smart glass that you would attach to your head like this, usually to your glasses, something in the sense, this. And you would have a handheld device, which basically, based on what the sensor is getting as a feedback, it gives to the user a haptic feedback telling where the obstacles in the environment are. I can discuss a little bit, I can give a demonstration in the end if I have more time. If anyone is curious, you can also test to play yourself, or you can go deeper into it. But this is our first prototype that we developed. And the interesting part is, if all we want to do is this technology, just to be able to convert distance sensors of the obstacles, for example, to the user via haptic feedback, we were able to develop something as cheap as 3,000 yen in this context. So this device here, it costs around 3,000 yen to develop. We believe this cost can be even further reduced. The sensors we're using are very known in the market. They are nothing crazy. They are nothing like the processing power is not great. I'm gonna go deeper into details later. So this is the current idea. And it can also be integrated with other apps like maps and so on. So you can give like directional feedback to the user via haptic feedback. And the second proposal we have is the tornasol printer. This is, unfortunately, we're not able to produce a prototype yet, but we have some ideas for the printer. So first off, new primitives. By that, I mean, usually a primitive is like a very simple, the simplest thing you can make in a printer. So for example, in a standard braille printer will be a dot, and you can use the dot to build other things. We believe we can make like more complex primitives, which allow the user to draw graphs and so on, which in turn makes it possible for you to represent images, graphs, and everything in between. But we also propose building an API that enables users and ourselves to build different apps that can be integrated with the printer. And the estimated production cost for a printer like this, given our current market research, our current hardware research for the things we are planning to develop, would cost around 12,000 yen. In dollars, that would be a little bit below $100 right now. And the idea is that the social impacts of our products are pretty much the affordability. Of course, this is our main #1 concern, and the adaptability. So the user can change, make it fit their needs. You're proposing giving them full support to change the product however they want for software or hardware parts, and make it accessible so every single customer can easily go online and buy products. And our source of revenues for these products are, of course, as a hardware company, number one will be product sales. So selling our hardware, the user goes online, goes to Amazon, goes to a store, buys the product, the immediate revenue. And also in the case for the printer, of course, we have the refill things, be that in terms of paper, be that in terms of the other things we're going to use for that. And also the custom apps. Since we are enabling the opening the API, we can create something like an app store for our products. It will be easier for other people in our sector to create apps that can be purchased online later down the line. In our market, our number one users, the users themselves, number two schools, and local governments are also think will be able to benefit from those products. In terms of market trends, we can see that assistive technologies for the visually impaired specifically, it is a growing market, especially because the recent development in technology. So if you look here, for example, at the compound annual growth rate, it is at 13.8%. So if you project that from 2021 to 2030, it is a around 13 billion market thing that we are looking at, market trend. Now, looking a little bit more specific into the market for braille printers, if you look at the market, we have very few companies that share like a big chunk of the market nowadays. As I mentioned, the takeaway here is that they were created a few decades ago. They're very old. And if you look at their products, they haven't been innovating a lot in the field for quite a while. So the products they used in the 90s are pretty much what we have nowadays. And in terms of the navigation technologies, of course, as you mentioned, we have the classic ones, the white canes. We have white dogs. They usually suit different markets. They have very distinct prices. And as an emerging field, we have the wearable devices, where our product fits in. And our distinction in this market is, again, the price. Usually a smart glass, they are very chunky, they have a lot of features. They are very expensive, very inaccessible, while we are proposing something very simple that only addresses the immediate needs. Therefore, it's much more affordable. In terms of what the deployment plan, what we're doing for the company in our products right now, first off, for this year, we are planning on doing the pilot tests. So right now we have the first prototype, as I showed you. We are planning, of course, in making it better, making it a little bit, actually building an MVP from it. Doing the product market fit, so product market fit. So there is going to customers, talking to them, and seeing how they react to our products, and then finalize the designs, the initial designs that we have through like various applications, right? After that, 2026 will be launch here in Japan, in the US, and then apply the feedback from the customers, and from that scale and expand. Going a little bit more specific, now in 2025 was in the pre-seed stage. We were, on February this year, we were working on the conceptualization during the ISS-PBL class in this presentation. So the first deliverable was basically this presentation. From here on, we are planning on developing the MVP further, both of the MVPs. So we have the first MVP for the sensor, the spider sense, and we also plan on building the MVP for the printer. So we can show that to the customers, show it to people to actually test it out, the first versions. And also, in terms of deliverables for this stage, would be the first MVPs, of course, and our first 10 potential customers, which will be in contact with. And in December, lastly, also in this year, if we are able to continue this project through the on-site exchange program, we are planning on getting more users, getting their feedback, and then officially releasing, hopefully by the end of the year, the actual products after hearing all the feedback. So what we do right now is mostly, of course, feedback. More importantly, we're actively looking for mentors, be that in the sense of like releasing hardware. We all know it's very difficult to release hardware. It's much harder than software, as the name implies, even. And also user feedback in general. If you have any experience with assistive technology, if you have anything to say, please let us know. You can just scan the QR code and leave us a message. We'll like try to reach to you as soon as possible. That's it. Thank you.
Okay, thank you very much.
I was not, I did not understand how the spider sense works. Is that a LiDAR technology? Is that radar? Is that, can you tell us a little bit more about it? And normally, some systems require the equivalent of stereo vision. I only saw one point of where the sensor would work. Can you give us a little bit more information?
Yeah, first, currently I'm using a multi-zone time of flight sensor. So this is it's pretty well known. The sensor this basically gives you a matrix of distances, an 8x8 matrix, and then you convert those distances you map those to haptic vibrations basically. So the sensor that I'm using right now is this 8x8 time of flight sensor. We're planning on changing that in the future.
So if, for example, a blind person, there's a sudden step down, that's not something that would be reflective. How does your sensor communicate that to the blind person?
Right now, it does not. This version does not. The only thing we can detect is the distance and position of an object, the field of vision of the user.
Thank you.
I think it is very important to get the feedback from the user. In your case, the visually impaired person. So, can you develop your equipment together with the visually impaired person? Because otherwise, always visually impaired person is going to be just the user, not the developer. So I think the true inclusive society, the working environment is also very important. So I'd like to hear your opinion.
No, we also believe it's completely vital to collaborate with the visually impaired. Like the main idea of our products are to build things that solve their immediate needs. So that's why for the next steps, I think the most important thing we have to make is contact those people and get their feedback to understand what they actually need. Right? That I think is I agree, that's the most pressing need right now.
I fully agree to what the camera sensor said that. Because I'm wondering how many people with visually impaired you have interviewed for preparing this presentation.
We reached out to one person. She's an influencer she makes videos about visually impaired. So I was fortunate enough to be able to meet her from a person I know from Seattle. And but overall, this first prototype, it's not exactly what we want for the final product. It was just like a proof of concept, mostly for the haptic navigation part. But we plan on contacting, as I mentioned, many people to get feedback from our products.
Because I do understand, of course, that the difficulty to find even those that end users, but the people with sighted, which means that the many people who are able to see are also different. At the same time, people with the visually impaired are also very different. Even low vision has different types. So from my viewpoint, this could be very important to talk, and even if not even before development, you try to show that some of the mock-up and getting ideas, and this will be brush up your ideas very clearly. So I hope that, but I appreciate those kind of effort are very important. And not only for the market viewpoint, and not only for the people with visually impaired, most probably the people, elderly people who have that also decreasement of the mobilities, and those are also similar technology can be used. So, but I think one important thing is the first focus on what kind of visually impaired people most probably not a congenitals or congenitals, or even that the different the low visions. And this could be clarified. Then also your like product will be very much profitable. Thank you.
Então, with on that also. When we were thinking of the product, at first we were mostly focusing on functional blindness and low vision. But while looking at different diseases, the ones that are like developed with age, we got to discuss about glaucoma, for example, and loss of peripheral vision. And I agree that, especially for glaucoma, where you lose the center field of vision, I think it's very important to develop technology like that.
You know, just to share my story about that, I have been working on that the people with visually impaired since many years. And because we have that the Tsukuba University of Technology, which is just next to that University of Tsukuba, there are many students with visually impaired. And from those kind of many requests that came to me, oh, please, prof, I would like to learn to meet that, the classroom. So they would like to learn from the bus stop to the classes. I was very surprised at that. They wanted to learn, but still, and they say about that they can learn alone, but not wanted to disturb others walking. So like that, to clash and to meet and the people. And I think so. I was very surprised at that. So good things to talk many people. They have many different demand, which is that unexpected than us. Thank you.
Hello, thank you very much for your presentation. Your topic as well is also very important, and will become increasingly important, especially as people get older as well. I'm sure that the percentage of people who will have mobility problems will increase. I was wondering, you also mentioned that the predicted share of this mobility assisting devices is going to grow quite rapidly. This means there will be a lot of competitors trying to get in. I was wondering what was your competitive, if you could explain your competitive advantage of your design and your idea.
Thank you for the question. I think the main idea to make it be more competitive in this field is building a community, right? So that's what we are trying to address in terms of developing a platform where everyone can develop something. So here I mentioned about the Braille printer, for example, about user APIs that enable the development of custom software. That's what usually Apple does, for example, when they let the customers develop apps for their phones. Usually the current market for pretty much everything, it's very close. So you get what you pay for. You pay for a product. You cannot change that in any sense. And we are trying to actually create a community where people can collaborate and expand on the hardware that we build.
Okay, thank you very much, Group 2.